Yesterday we talked about all the four different conic sections. We worked on a little bit on circles, and then we did some stuff on ellipses. Today we're going to focus on circles, which really is the easiest conic section to deal with. So, imagine we have a circle centered at the origin, and we don't know the radius, but we do know one point on the circle is at 6, 8. How do we find the radius of the circle? What's that? Okay. Well, this is obviously not the scale, so ruler won't work. It's a right triangle. Well, the hypotenuse of the right triangle is what we're looking for. What is the length of the bottom leg of the triangle? 6, and the right leg is 8. So we're just going to plug that into a squared plus b squared equals c squared. So a would be 6 and b would be 8. So 6 squared is 36. 8 squared is 64 equals c squared. 36 plus 64 is 100. How do I find the radius? Square root, both sides, and I get c equals, don't forget the rule, plus or minus 10. Well, does the negative make sense? No, you can't have a negative distance. So for this problem, we can ignore the negative, but later on today, we're not going to ignore the negative. So the radius would be 10. Okay? Well, what if I want to create the equation of any circle centered at the origin? So here's a circle. Center is at 0, 0, but I don't know any of the points on the circle. So I'm just going to call this point here x, comma, y. Now the picture makes it look like xy is in quadrant 1, but really it could be in any quadrant. Because x could be any real number and y could be any real number. So really the point is wherever we want it to be. Okay? So let's plug that into the Pythagorean theorem. What is the length of the bottom? X, and we're going to square that. So x squared plus y squared equals c squared, which is the same as r squared. And that's the formula for a circle, as long as it's centered at the origin. And when they're centered at the origin, it's really nice, because usually the math is super simple. Okay? In this bottom problem, we're going to move the center to some unknown distance. For all conic sections, the center is always labeled as h, comma, k. H is some unknown x value, and k is some unknown y value. So in a circle, hk is obviously the center. If it's an ellipse has two foci. And the center is halfway between the two foci, and it's also called h, comma, k. In a parabola, and we haven't talked about this yet, but in a parabola, the vertex is at h, comma, k. And then the last one is a hyperbola, which we're not really going to talk about today. And a hyperbola has two vertices. It also has two foci. Halfway between the two vertices is the center h, comma, k. And really, all the formulas are very similar to one another. And we always use the center as h, comma, k. All right, so we know the center is hk, and I know that the point on the side is x, comma, y. So if I call this bottom leg a, what is the length of a? Close. Not h plus x. It's either h minus x or x minus h. and we are going to label it as x minus h. I don't know what x is, I don't know what h is, but whatever they are, that length of that bottom side is x minus h. So a equals x minus h. Now what do? Square it. I'm going to add that to y minus k. Is it going to be, does it matter if it's y minus k or k minus y? Well, not really unless you label the other one that way. So if on this first one you do x minus h, then on the second one you will have to do y minus k. If you did h minus x, then you could flip the other one. But they have to match. So y minus k squared equals r squared. That is the general formula for a circle. That represents every possible circle. Now, there are a lot of unknowns there. We don't know the center and we don't know the radius, but that covers everything. Okay, so look down at problem A. So we need to create the equation. Well, h comma k is 0, 0, so that's nice. And my radius is 4. So all I need to do is plug that information into the equation. What is x minus h? X minus the x value in the center is 0. So it's just x squared plus y squared equals 4 squared, which is 16. Does that make sense? How do we graph this? Well, if we go into our y equals, you have to graph it in this form. Well, it's not in that form, and there's another problem. Is a circle a function? Not even close. It fails the horizontal line test everywhere. So we need to solve for y. So how can I change this equation to solve for y? Minus x squared, so I get y to the second equals 16 minus x squared. Now what? Square root, and I get y equals, wait, plus or minus. Can I write 4? No, this is a difference of two squares. So it's actually 4 minus x and 4 plus x. So you can't square root it. So it's just the square root of 16 minus x squared. All right? So we're going to have to graph two different equations. So the first equation is just the square root of 16 minus x squared. And the second one is negative square root of 16 minus x squared. Okay? So we graph that. And I see a couple problems. First of all, it doesn't look like a circle. Second of all, it didn't actually go down and touch the x-axis. So the second problem is really easy to understand. The resolution of this screen is so poor that when the graph gets super steep, the calculator just gives up. So it really does touch the x-axis, but your calculator kind of freaked out and said, I'm not working that hard. What about the fact that it's more egg-shaped than round? What's wrong with the screen? Right, so in the standard window, the x values go from negative 10 to 10, and the y values also go from negative 10 to 10. So we're looking at a square screen only our calculator is not square, it's rectangular. So it had to pull that x-axis out in order to make it fit, which stretched the circle. But the people who built the calculator knew that was a problem, so they put this in. If you go to zoom, number 5 says z square. What that will do is keep adding x values until the length of the x values is equal to the length of the y values. So if I push zoom square, now it's circular, and we still have that problem where it's not touching. And my smart board distorts things a little bit, so on your screen it will look more round than mine does. Well, I don't know, that looks pretty good. It looks good. Okay, let me show you a trick that's really nice. If you're going to graph plus or minus the square root of 16 minus x squared, once you graph the first one, you can tell the calculator to just graph the opposite of the first one. So go into your y equals and clear out the second equation. The first graph is labeled as y1. The second graph is just the negative version of y1. So I'm going to push negative, and then I'm going to go into variables, and I'm going to go over to y variables. We've done this before. Go into function, and there are all of the y variables that you want. I'm just going to hit enter on y1. So I'm going to graph y1, and I'm going to graph the negative of y1. And then I didn't even need to type any of that in, and it will draw the graph for me. So that's kind of nice. So whenever you're drawing circles, although it does get a little more complicated in a minute, but if you graph the top, then you can graph the negative version on the bottom, and it will do it for you. Okay. Let's save this. Okay. Next circle. My HK is 2 comma negative 3, and my R is 3. Everybody agree with that? All right. So my formula is going to be x minus the x value, which is 2, squared, plus y minus negative 3, which is actually plus 3 squared equals 3. Because it's a squared plus b squared equals c squared. So 3 squared is 9. All right. Now we need to solve this one for y. So I'm going to move x minus 2 to the other side. So I have y plus 3 to the second equals 9 minus x minus 2 squared. Everybody understand that? All I did was move the x portion to the other side using subtraction. What's my next step? Square root it. So I square root both sides. Can I simplify the right side? No, because it's a polynomial, 9 minus this, so no, you can't. So on the left side, I'm left with y plus 3 equals plus or minus the square root of 9 minus x minus 2 squared. Now, if you have the old software on your calculator, you're going to need to put parentheses around this. Mine, you don't have to, but a lot of yours you will. Now what do? I need to move the 3 over. So I have y equals plus or minus the square root of 9 minus x minus 2 squared minus 3. Okay. Let's type this in. So the square root of, and I'm going to put the parentheses just so you guys know what I'm talking about. Parenthesis 9 minus parentheses x minus 2 and then another parenthesis, and then outside of that I'll have a minus 3. Okay? And then we can try to graph the bottom by just doing the opposite of the top. So I push graph, and oh, that looks nice, but that does not look nice. Why didn't that work? First of all, did anybody not get that? You added 3. You're supposed to subtract 3. And you don't need those parentheses. Anybody else not get this? I mean, it's obviously wrong, but if you didn't get that, then you've made a mistake that I didn't make. So let's look at it. The first part we graphed, the top half was correct, but the bottom half landed in the wrong place. How come? Well, the top half is plus the square root of 9 minus x minus 2 squared, and then minus 3. If I change all of these signs, then I get negative square root of that stuff plus 3. What's wrong with this? The plus 3 is supposed to be a minus 3. So what can I do to bring this back down so it's a negative 3? Subtract 3 twice. Because if I subtract 3, it will bring this down to a 0. If I subtract it again, it will bring it down to a negative 3. Now, if you don't understand that, just type the second equation in. So I need to go back in here, and I need to do my y1 minus 6. And I'll pull that graph down to match where it's supposed to be. And again, if you don't understand that, that's fine. Just graph a positive version of the square root minus 3 and then a negative version of the square root minus 3. Anytime you have a constant out here, the negative y1 is not going to work. Anytime your center is above the y-axis or below the y-axis, that negative y1 trick isn't going to work. You either need to not do it that way, or you need to compensate by adding or subtracting double what you did before. Okay? As long as it's on the x-axis, though, it's not going to matter. All right. Number C. So my center is negative 3, negative 1, and my radius is 6. So what is the formula going to look like? X plus 3 squared plus y plus 1 squared equals 36. We don't need to graph that in our calculator. It's already graphed for us. We just needed the equation. Okay. So look down at part D. So, part D. Where is the center of that circle? Oh, shoot. So the center, oh boy. Oh, that's not working. We'll do it this way. So the center is at 0, 0. What's the radius? No, r squared is 4. The radius is 2. For the second one, where is the center? No. 4, negative 2. Because remember, H and K are opposite of what it says inside the parentheses. So the center is at 4, negative 2. What's the radius? So it would look like that. All right. Part F. Where is the center? 1, 0. And the radius is 5. So circles are pretty simple. Your assignment is to finish the back side of this and hand it in. You should have plenty of time to finish before the bell rings. Good luck.